Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hanafi Adli bin Ahmad Sobri, and my metric number is CE190071, and I will be presenting for my final year project, which the title is Speed Control of BLDC Motor based on PID Fuzzy Controller. So first of all, for the introduction part, so BLDC motor utilize no brushes commutator to exchange the current in the armature coil. Therefore, they have fewer mechanical parts. It is vital to explore BLDC motor speed control in order to improve the app capability. So, a good controller is necessary in many applications for a BLDC motor to manage its speed and react to load variation. Once the load vary, a controller for BLDC motor must be created to manage and maintain the speed. Next, for the problem statement. So, as I do the research, so BLDC motor is a non-linear motor because it is very sensitive to the load disturbance and parameter variation that can change the speed from the constant speed that has been set up by the user. So that is why the control is very important in BLDC motor operation. So many method has been done to control the speed of the motor, but the method are not promising enough to adapt with the disturbance and variation. So this is the objective for my project, which is I need to simulate the model for the BLDC motor drive system using the MATLAB and Simulink. After that, I need to create a proposed speed control using the PID and PID fuzzy control. So after that, I need to verify the performance of the proposed method by using the simulation that I have done earlier. The project scope from this is this project will focus on design the controller for BLDC motor to keep or maintain the motor speed constant under load variation. So the software that will be used is MATLAB and Simulink. So after we done the simulation, after I done the simulation, I need to make an analysis from the result from the simulation in order to make sure that the result from the controller can be acceptance. So this project will be focused on method how to control the speed of BLDC motor to make sure that the motor can operate well in load disturbance condition. So for the methodology part, so this project began with the establishment of the project objective, which is we got a few objectives that will be met after finish this project. So from the flowchart here, we can see that first of all, we need to before we start the project, we need to determination of the project objective. So after we got the objective of this project, we need to perform. After I got the determination of this project objective, I need to perform the research and study from the previous word. After done the previous study, I will be conduct, develop and design the PID controller. After that, I need to do one more design for PID fuzzy controller, which is two different things between PID controller and PID fuzzy. After that, I will run the simulation. If the simulation is not succeed, I will do the design again for PID and PID fuzzy. If the simulation is succeed, um, and I will be the PID and PID fuzzy controller comparison. So from this comparison, we will know what is the difference between both of the controller. After that, I will be do the result analysis, and that will be the end of the project. So for the result, for no load condition, firstly, this project run the simulation when no load apply or constant speed for the BLDC drive system when using PID and PID fuzzy controller separately. The testing condition for this project are 3000 RPM, 150 RPM constant speed, um, 1000 RPM and 500 RPM. So this is for the load disturbance. Next for the BLDC drive system with the speed controller under load disturbance condition, they are initially running at defined reference speed with no load condition. Then the load is immediately adjusted to 0.2 at 3 seconds for both PID and PID fuzzy controller. So this project will be inject with 0.2 uh, load disturbance or load torque because of the calculation have been made. So this is for the load disturbance uh, at speed 3000 RPM for load disturbance, and this is for speed at 1500 RPM for load disturbance. So this is the result when speed at 1000 RPM for the load disturbance, and this is the speed at 500 RPM of the load disturbance. Mm, so the speed response waveform for a BLDC motor when implementing a PID controller and PID fuzzy controller under load disturbance condition is demonstrates, and all of this is the result that I got from the simulation. Next, moving on to the settling time. So this project decide to record the settling time for every testing condition, whether no load or load disturbance condition, in order to prove the performance of PID controller to control the speed of BLDC motor. So in comparison to PID controller, table 4.1, I have put it at the side of this. So it clearly that employing the PID controller require less settling time. So when using PID fuzzy for any testing scenario, whether steady speed or load disturbance settling, the settling time is reduced, as we can see from the table. So for the PID constant speed, the settling time for the constant speed without load, so with the 500 RPM, so the PID result is 4.546. So for the PID fuzzy is 1.1650. So for the load disturbance is 1.5650, and the PID fuzzy is 0.059. So clearly we can see that by using the PID fuzzy, so the settling time is reduced than the PID controller. Okay, moving on to the conclusion. So this project, that the main benefit of fuzzy logic is able to deal with non-linearity like load disturbance and the parameter variation system for BLDC motor. So fuzzy logic also has made advantage that human can see or get from recent study, that it will be the reason why PID fuzzy controller is suited to be the method to control the speed of BLDC motor. And lastly, the PID fuzzy controller that have been proposed and designed in this project to control the speed of BLDC motor by keeping the motor speed constant when the load change was proven, and it is succeed. Yeah. So lastly from me is the recommendation. So the recommendation from this project that it can be done is to use another tuning technique apart from Ziegler-Nichols technique for tuning the PID parameter gain, in order to get a better result, like reduce the steady state error. And another one is that can be done for this project is use the genetic algorithm to get the optimal parameter for membership in the PID fuzzy controller. Okay, that's all from me. Thank you.